All right. I think we are live. I'm just going to check real quick. I'm not in my normal setup today, so just want to make sure everything looks good. If you guys can hear me okay, the mic is probably not going to be the best quality because it's just my internal mic today. If you can let me know in the comments if you are here, if you can hear me okay, all of that. I'm going to check on my end as well. Good so far. Let's see. Streaming. Looks like LinkedIn is having a little bit of an issue right now. Trying to troubleshoot. Let's see. I'm just gonna check it on YouTube real quick because it looks like LinkedIn might have an issue. Let's try this. Okay, looks like YouTube is good. I'm restarting the LinkedIn connection, so hopefully this works. Yeah, that's unfortunate. Might not be live streaming to LinkedIn because there's okay. It's fine. As long as it works on YouTube, that's probably fine. It's probably not gonna work on LinkedIn. All right. So anyways, thank you guys for joining. Try to do these monthly live streams, just kind of talk about what's on my mind, do any Q&As and things like that to engage with folks. I figured today I'd talk a little bit about my experience with some of the Stanford classes that I'm taking, because I just finished my most recent one, which is the Modeling Biomedical Informatics, Biomedical Systems, which let me just link that below in case folks are interested. I know there's been quite a few folks that have been asking me about my experience with these classes. I'm going to post this one here. There it is. So this is the most recent one I took. This is Modeling Biomedical Systems. The last one I took was Data Science for Medicine. I want to share a couple of things that I thought about from that class. And we'll be starting my next one, which is, let me link that one too. Let's see. That one is Computational Methods for Biomedical Image Analysis and Interpretation. I might talk a little bit about that one too afterwards. That one starts next week. So maybe to start with the first one, which is Modeling Biomedical Systems, a couple of thoughts. I think it's a very good general course, especially for people who have an interest in representing healthcare in a machine readable format, if you will. I think what's interesting about this course was like for probably the last 6 years, 5-6 years, I've been trying to figure out what is the degree that I would want to get to be able to represent healthcare in a way that you can exchange information between multiple entities. If it's like from hospital A to hospital B, hospital A to pharmacy A, things like that. And I think this course did a pretty good job of framing how to think about that. So again, the name of the course is Modeling Biomedical Systems. And I think why that was the case is because it taught you a couple of things, and maybe at the highest level, the first of which is how do you engineer knowledge, or how do you represent a particular domain in healthcare? So let's just say infectious disease. Like, what are the different components that go into infectious disease? There's like a antibiotic or antimicrobials for that matter. There are the bugs or the organisms, the bacteria, the viruses. Then there's like the different lab tests that go into it. There's the different diseases like pneumonia or urinary tract infection, those kind of things. And if you can think about this domain, the course teaches you how to model that in a way that you figure out how best to describe it. In a way that you can extract information from it that's useful. So in short, they teach you how to build knowledge graphs, ontologies that can be used in some type of intelligent medical system, which is super cool. And I think a lot of us who build within EHRs do that, but we don't typically do it in a way that's like a systematic, a methodical, how do you say it? A way that's scalable, portable, logical, all those kind of things. We just kind of build. So I thought it was really cool to do that. So that's the one big part of the course, which is teaching you how do you build and represent knowledge, right? The second part is really cool as well, where it teaches you how to actually take the information from these systems and do something with it. Like if a patient comes in with this disease and this organism growing, what antibiotic do you want to use? You can basically use these, you can think of them as problem solving methods or PSMs, and how you would solve a particular problem. So you query this knowledge, this like knowledge graph or ontology or this knowledge base, whatever, grab the information needed, reason about it, and then spit out a recommendation. So the course was really cool from that perspective. The professor, Mark Newson, is amazing. All the TAs were absolutely fantastic. A very useful course, something I highly recommend. It was definitely less technically challenging as opposed to the first course I took, which was data science and medicine. That was pretty intensive. This one is much more rudimentary in the technical aspects, but it was certainly very foundational, a lot of concepts. In the beginning of the course, for example, there was a lot of talks about representing knowledge using first order logic, which is quite mathematical. So like, I don't know what's the best words of describing it. It's very abstract. Let's put it this way. If you just Google like first order logic, let me see if I can find, yeah, I'm just gonna copy this and paste it in here. If you just take a look at first order logic, you get an idea of what that means. But it's very cool because it's just like, how do you represent anything in the world? And so it started with that kind of abstract level of how do you build knowledge systems. So super cool. But some of the other things that were really cool about the class that I really enjoyed was the simplicity of doing something with that knowledge after. And there's a couple of examples. I think the first one that really blew my mind was, well, I'll say a couple things. The first one was you can take these ontologies you built, which we used a open source free tool called Protege. I'm actually going to post that in here in case anyone is interested. We use this tool to basically build our knowledge base, whatever you want to represent. It doesn't have to be healthcare. It could be like selling cars, for example, or health insurance, something like that. You use this free open source tool where you build this knowledge, and it's a way of building it that is much more scalable, which is really cool. And then you can take that knowledge and import it into Python to perform different tasks with it. So it's really cool because everything's free. You can do all this open source. It's easy to do. Anyways, that's one thing. Going to the other two things that I thought was really cool about the course was I shared it in some of my posts before, but it was the ability to build simple Bayesian networks based on some data set to produce some intelligent outcome. And so I'll give an example. And I talked about this in the post. Let's pretend you have an Excel database or Excel spreadsheet, right? And it's like millions of lines long, and each row represents a single patient. And the first column represents the diagnosis, and all the other subsequent columns, it could be like hundreds or thousands of columns that represent the different symptoms that a patient might have. So let's say it's like the first line would be the first column is the diagnosis, like hypertension, for example. And then the second column might be nausea. The third column might be syncope. The fourth column might be night sweats, whatever. Like basically those are all the symptoms. You can take all this spreadsheet and basically put it into a Bayesian network, which is super simple to do in Python. There's like a library for it. You can just call the library, and say, bring this spreadsheet into the model, create this Bayesian network for me. And then once that's done, you have, oh, I just realized that there's there's a lot of graphics on my screen here. Let me turn that off, actually. It's a little annoying. There it is. Anyways, so you can put this into a model and you can ask questions about it that basically say, if a patient has nausea and syncope, what is the likely diagnosis? And all of this is based on probability. That's what Bayesian nets are. But it was super cool to see how simple it was to build something very unique and I think would be very useful in healthcare within like, I don't know, this probably took like 30 minutes to build. Super simple. And again, very super useful. So that's one thing. The second thing that really blew my mind, I didn't get as much chance to explore, was the ability to parse out concepts and entities of interest from just words, like let's say clinical notes, for example, or even research articles. And what was so fascinating about this, and I'm probably going to butcher the way of explaining this, is like imagine you're a researcher and you're trying to come up with a new hypothesis about whether or not this new drug would work for this disease. You might do like a exhaustive literature review of, I don't know, hundreds of articles, right? That could take a lot of time. And you have to be able to summarize all of those findings to figure out what are the patterns and relationships that you need to extract from it. So a lot of time, right? What's cool about the second thing they taught us in the course was how to use natural language processing methods. Two very basic ones. I'll post in the chat just in case you guys are interested. I think it's bag of words. These are all methods, by the way. So this is one of the methods. This is bag of words. And then there's another one called word to vec. And I'm not to say these are things that I'm saying you should use. These are just examples, very simple examples you could use to do this. I don't know if how often people use this in like production systems or anything like that. They probably do, but anyways. So these are two methods you can use that basically will take, let's say a research article, and be able to parse it for different entities of interest. I can't go through exactly how they do it. The methods themselves describe how they identify the relationships, but you can think of it simplistically as they can read an article and extract the concepts of interest from it, okay? Which is what we care about. So things like pneumonia or a drug or a sign or symptom from it. All those entities gets extracted out. So that's what these methods could do. So after you extract it out, there's another thing that they taught us in the course, which was super cool, is you can link this with UMLS, which if you're not familiar with, is a very useful tool for tagging things. So here's UMLS, tagging things with a semantic code, if you will, like a standard controlled vocabulary, like ARCS norm, SNOMED, things like that. But first, they'll tag it with the UMLS concept identifier. And then you can link that to whatever other standards you want. But it's super cool because you can basically take free text, parse it into these concepts, match those concepts to some standard, and then we can perform different things with it to identify new relationships. So for example, if they always identified, these antibiotics being associated with, or in reading these hundreds of articles, they always found that antibiotics were associated with GI symptoms like diarrhea. You can do that very quickly with these tools, which is what's mind-blowing. And I don't know if that's of interest to a lot of folks out there, but it just blows my mind because you can come up with all these sorts of ways of identifying new relationships, especially for research. So drug research is a big one. I know that one of the examples that they showed in class was this is how one of the COVID meds got discovered, which was very cool. They were looking at molecular structures and looking at what was working for COVID and identified new drug targets and potential drugs that could be used for COVID as well. And it was one of the ways that got that drug approved by the FDA. So these are just like very useful and valuable tools that I think if clinicians had better understanding of, we can do a lot of great things in general. Looks like, unfortunately, LinkedIn is still not up. Well, that's my main thoughts about the class. If you are, maybe I'll post it in the chat just in case. Well, let me post a couple of things actually. So with all these live streams, if anyone has an interest in jumping on and chatting with me, I always make a link available. You can do so by clicking that link. Does that even look right? 1 second here. Yeah. This actually doesn't look right. Oh no, it should be. Yeah, you can click that link and you can join the live chat, and I'd be happy to chat with you. Otherwise, let me link that course that I was talking about. It was the modeling biomedical informatics, modeling biomedical systems. There it is. So everything I just said was related to this course I just took, modeling biomedical systems, and highly recommended. Definitely check it out, especially if you want more of a conceptual level of how do you represent things. The other one final thing I'll say about the course is that it went into pretty detailed, very deep dive of the history of how these systems kind of evolved, which is super interesting. So you can kind of see like the thought process of like how we design more and more intelligent systems and how some of those methods have changed over time. Now, I'm going to switch over to the next one, which is this one. Okay. So this is the next course I'm taking. I'll be completely honest. I'm a little worried about this one. One of my classmates that I'm going in class with right now, she was mentioning that this course and reading the course description, it gets pretty deep into deep learning, which is a little scary to me. And specifically CNNs, which is convolutional neural networks. Really don't know much about either deep learning or CNNs, but I spent the last week kind of going through different intro videos to just get a better idea of how it works. And I think it's going to be pretty challenging. Let's see, the prereqs for the course is basic stats, biology, familiarity with Python, and then highly recommended that you have good working knowledge of both MATLAB or Python. So I think that the course, even based on the sequence number and the descriptions, it seems like it'll probably be one of those like more technically challenging ones, which to go back to the data science for medicine course, that one I probably spent 25 to 40 hours a week on that course alone. So it was pretty challenging because I think most of my knowledge gaps are within the technical realm. But it should be pretty interesting. And as I learn more about deep learning, it seems like this course really teaches you how you can, I'm assuming, build deep or use deep learning to do stuff. Let me think of a better example. So one big one that comes to mind is computer vision. I guess this is the type of technology that is used heavily in computer vision. So you can think about like the autonomous cars when they're driving, you can like recognize patterns. You can, and I guess for imaging purposes, it's like, how do you recognize different, what what are the contents within X-rays or ultrasounds or MRIs, things like that. Like, how do you recognize things? And what deep learning does, from what I'm gathering, or specifically CNNs, is it is like there's an input and there's an output. Your input is the image of interest, and your output is like, what is this image about, right? And then within here are a bunch of like nodes, and they call them like hidden layers. But basically, each one of these nodes kind of extracts different features from the input. So, like, let's say you have a picture, an image of a face. The first node kind of goes through and draws out like an outline, and it recognizes, oh, this is the shape of a circle. Like, my face looks like the shape of a circle. And then the next layer will go through and like say, oh, there's eyes. So you can recognize eyes. So now each layer, it draws more and more of those features. And then the final output would be like, based on all these different features is a face, and that is my very rudimentary understanding of how do you apply CNNs and deep learning to do computer vision or I guess like imaging type stuff. So yeah, I'm excited about it. It's a little scary. This might be one of the first courses I might drop. We'll see what happens there. But it's fascinating. Again, going back to the reason why I'm talking about all these things, especially with the course and then with ChatGPT as well, is the fact that there is, I think, a lot of potential in going from using the quote that Peter Thiel always talks about, which is zero to one. I think putting ChatGPT in the hands of clinicians really allows us to go from 0 to 1 in the development of these types of technologies, which is super cool. Of course, I should always give the caveat that the potential is really high. It's great, but we should also be very, very skeptical and wary about the possibility that these things are wrong. And I think I mentioned in the past, but these things are wrong very often. So, and that's probably not the most accurate to say. I think some of the rudimentary analysis of things like ChatGPT 4, the results I'm seeing is pretty good. Does it mean we should trust it? Not necessarily. I think there's definitely a lot of work that is still needed in the space, but it's an area to explore is what I'm trying to say. And I'm trying to, with my platform at least, trying to get more clinicians interested in learning about these technologies, learning about like AI, for example. How can we apply AI to healthcare? And then potentially using ChatGPT to help us in building some of the software that can get us there. And we might not be the ones that ultimately do the final checks of the program to make sure it's running correctly and things like that. We would probably check more of the clinical validity of it and whether or not it's doing what it's supposed to. But it can help us get started with different templates to just kind of test ideas and our hypothesis. And then ultimately maybe pair with a computer scientist or a software engineer to really refine what the code we're writing is doing and stuff like that. But I think that is the main things I wanted to chat about. It's unfortunate that this didn't go on LinkedIn today, probably because of my network connection. It's not the best. But hopefully this is interesting to those who are contemplating going deeper into the technical weeds of things. I know like over the last few months, there's been a lot of folks that have been reaching out about whether or not they should pursue things like data science, software engineering, biostats, things like that, and what makes the most sense for them. So I'm trying to talk more about this to, kind of shed my experience. So I think I'll wrap it up here. It's been going on for 25 minutes. And if you have any other questions, definitely leave it in the comments, and I will respond when I get a chance. But All right, guys. Thanks for tuning in. I'll see you in the next one.